Hi everyone, so in this lecture we will discuss a new property of a Laplace transformation, that is effect of a multiplication by t. To prove this property, just consider it's a question. Prove that Laplace of t into f of t is equal to minus 1 d by ds of phi of s. This can also be written as like this, that is a minus phi dash of s. To prove this statement, our first step will be, that is our definition of Laplace transformation, as we have already discussed in previous lecture. That definition is, that is when we have a function L of ft, then we can write it as like this, that is take integration from 0 to infinity e raised to minus st into this f of t, write it as it is, that is f of t into my dt. Okay, we denote this as a phi of s, and we denote this equation as a equation number 1. Now next step is, observe one thing in our given statement. Here derivative is there, therefore we have to differentiate our equation number 1 with respect to s, because here we have a derivative with respect to s. This is possible just because of this statement, therefore we will differentiate this equation number 1 with respect to s. So its LHS becomes, that is d by ds of this total term, that is Laplace of my f of t. Okay, so this is my first term. Nextly, this phi of s, I can write it here, that is phi of s, that is d by ds of my phi of s, okay, is equal to, now differentiate this term also, that means take integration as it is, that is 0 to infinity. Here f of t we will treat as a constant term, because this is only function of a variable t, but we are differentiating with respect to s. That is why this term we will treat as a constant term, that is f of t. And when we differentiate with respect to s, then this function, that is d by ds, will convert it into dou by dou s into this e raised to minus st, okay, and into this dt we will write it as it is. So this is my term. Now after solving, there will be no change here, there will be no change here also. Only here we can observe that here we have a function of s variable, yes we have it, and similarly we are taking its a derivative with respect to s, therefore take its a derivative, then we will have this term as a integration 0 to infinity. There will be no change in first term, therefore f of t we will take it as it is, into dou by dou s into e raised to minus st. That means e raised to minus st we will treat as it is, into derivative of this term, that is in this power, then derivative with respect to s, s by s, that is dou s divided by dou s will cancel to each other, remaining term is a minus t, therefore we will write it as like this, minus t and dt as it is. And this term is also, we can replace it as like this, that is a phi dash of s, and this term, that is a d by ds, will remain as it is, that is L of ft. Now just take this minus sign outside of this integration, then we will have this minus integration 0 to infinity. We will just rearrange these terms. Then first term is e raised to minus st, our second term will be this t into f of t into my dt. So this is my second term, okay, and this term is equal to how much, phi dash of s, then we can write it as like this, phi dash of s, and this is equal to this, then we can write this or this, therefore we can consider this phi dash of s as it is. So we have obtained this integration, and this integration is what, just observe our equation number 1. When we have this integration and its value is equal to how much, L of ft, whenever we have a function here f of t, then we can write it as a Laplace of f of t. At that time integration, that is t has a range from 0 to infinity, e raised to minus st and dt. Similarly, we have now obtained integration from 0 to infinity, yes, as a equation number 1. Similarly, there will be no change in first term, that is e raised to minus st, and dt will remain as it is. There will be only change in this term. Therefore, here we have a f of t, then we will write here as a Laplace of f of t. Then we can write here also this term as a Laplace of my this function, that is t into my f of t. Okay, and take this minus sign as it is, and this is my phi dash of s. Okay, so that means just write this equation here, that is on LHS, that is a Laplace of this my t into f of t. okay, is equal to this minus side shift towards to this side, that is a minus of my phi dash of s. Hence we have obtained that is a new property of a Laplace transformation. That property is the effect of a multiplication of t with respect to any function f of t. Then we can write minus f dash of s. This can also be written as like this, that is Laplace of this t into f of t is equal to minus 1, take it as it is. Here we have a power, t has a power 1, therefore write here 1, okay, and this phi of s means it's a derivative is there, therefore we can write it as like this, that is d by ds of my phi of s. So this is my formula, and here we have a t raised to 1, therefore we can write this derivative raised to 1, and this is nothing but our this formula. So we have obtained Laplace transformation of t into f of t, that is effect of a multiplication by t. And whenever we, okay, so this is our formula for a multiplication t with respect to any function f of t. Okay, nextly, when we have Laplace of t square into f of t, then we can write this RHS as, write this minus 1 as it is. Here t has a power 2, therefore we can write this as a minus 1 raised to 2. Again this d by ds, take it as it is, therefore d by ds of phi of s will remain as it is, but here we have a t has a power 2, then we can write as a d by ds raised to 2. Okay, similarly we can obtain third equation, that is Laplace of t raised to 3 into f of t. Then we can write this minus 1 as it is, d by ds as it is, into phi of s as it is. Okay, there will be only change here, that is we have a t raised to 3 power, then we can write this minus 1 raised to 3 and d by ds raised to 3. Okay, and so on. When we find Laplace of t raised to n f of t, at that time we can write it as like this, that is minus 1 raised to, here we have a power n, then we can write it as a n, and d by ds of phi of s. Okay, and similarly d by ds will contain this power also, that is raised to n. Hence we have obtained these new formulas for multiplication by t, for multiplication by t square, multiplication by t raised to 3, and so on, multiplication by t raised to n. And with the help of this formula we will solve its corresponding examples.